Alright, so the problem we're going to tackle today, we're going to do one similar to number 5 here, where it gives you 2 PI points, and it wants you to lay out technically a compound curve structure. It's not really a compound curve, the way that this one's structured. So we'll do one similar to number 5. I'm not going to, just showing it here because, so you know that this is the one we're going to tackle. And then after that, we're going to hit one similar to number 6 and one similar to number 7. Okay? On the homework. So let's tackle one that's similar to number 5. So this will be, I'm going to call it example number 4 because this will be the 4th example that I've done. And this will be, we're going to talk about station equations today. Ooh, gotta fix that. Okay. See if this helps. It makes it sort of dark in here. Alright. So things that we know, if we look at number 5, they tell us our PI, our radius, and our station at I. So, or not station, but the I angle. So I'm going to give you our known, and I'm going to say PI1 is equal to 20 plus 25. Our radius 1 is 1200.00. Our I1 is 10 degrees, 00 minutes, 00 seconds. And then we have the information for the second curve. The PI at 2 is equal to 30 plus 00. Actually, we're going to go 31 plus 00. 31 plus 00. R2, radius at the curve 2 is 600. And the I at number 2 is 18 degrees, 00 minutes, 00 seconds. Okay, so that's what we know. Is that thing focused all right? Are those numbers hard to read?
Yeah, a little bit. It's washed out. It's great.
Ooh. That better? Yeah.
Yeah.
Or what this is. Oh, I can rotate it. Alright. Okay, so that's all the stuff we know. So I'm going to just draw some curves out here so I can write my information on it. I'm not going to do them to scale right now.
Do they have to be the scale and then
Yeah. They should be the scale. Okay, so I'm going to draw my PIs. So this is PI1. This one's PI2. Okay. And my curve looks something like this. Okay. So this is my PC at 1, PT at 1, PC 2, and PT at 2. Okay, so that's sort of what my curves look like. Not to scale, like I said. When you go to draw these, I want you to draw them to scale. So one thing it's a good skill to have. I don't know if Tim teaches it in civil or intro to civil, how to use a scale from graphing paper, but my second year students in the highway surveying class, I asked them to draw some stuff to scale on the test, and I didn't give them a scale. All I gave them was graphing paper, and all of them were asking why they didn't get a scale. I told them they had a graphing paper, they should be able to do it with graphing paper. So 5 squares is an inch on graphing paper. So it should be pretty easy to do with something to scale. You guys can do the same thing here. So, all right. Where do we start? Well, let's talk about this whole station equation thing that we're going to introduce here. So, in order to figure out stations, we need to know 3 simple things. So, our PC is equal to the PI minus T. T is the tangent, right? So that's the first thing we're going to need to know. Then our PT back, okay, this is a new concept. PT back is the PC plus L. So that's basically how we figured out we were going to find the PT to begin with. But when we do station equations, we need to have a PT back and a PT ahead. They're going to be 2 different things. Okay? So the PT back is the PC plus L, the Vilenka curve. PT ahead equals the PI plus the tangent. PI station plus the tangent is the PT ahead. You'll see why we do this here in a second. Okay? So if I ask you to figure out the PT ahead, you're going to use PI plus T. You're going to figure out the PT back, you're going to use the PC plus L. 2 totally separate numbers. Okay? So our PI 1 is 20 plus 25. Okay? First curve here right now. Let's figure out what our PC is. How do we figure out what the PC is?
PI minus T.
Yeah, so we don't have T up there, do we?
No.
Let's find T.
It's R tangent half pi.
So T1 equals R1 tangent I1 over 2. Okay, I'm calling it 1 because we're in the first curve. That's why I'm putting those 1s there. That way when I come back and look at this, I know that that's what I was figuring out. I don't confuse measurements. So that is, the R is 1200. Tangent of I, which is 10 degrees, 00 minutes, 00 seconds, over 2. Now, when you guys are calculating this stuff in your homework and stuff, please write out, I know it's just 10 degrees, please write out the minutes and seconds, even if it's zeros. I don't like it when people, even like the radius is 1200, right? 1200.00. I'm going to start marking off for not carrying out the right number of digits. So what's T?
104.99.
104.99.
Second.
So that's T1. Okay.
Feet.
That is in feet. That is in feet. Alright, so now we can figure out our PC, right? Because of this here. So our PC is the PI minus T. So what's our PC? PI, or PI minus T. Bueller. Bueller. Anybody have it?
1920. Or is this got to be the plus?
It's a station. 19 plus
Yeah, plus 20.01.
01. Okay, so our PC station is 19 plus 20.01. And that was based off of this. Okay? Alright, well, we can easily find our PT ahead, but we're going to have to do more work to find our PT back. So if we want to figure out our PT ahead, we can do that right away. What is our PT ahead? It's the PI plus T. Well, we have T and we have the PI. What's the PT ahead?
I got 21 plus 29.99.
Okay, so we found our PT ahead. Well, we want to be able to find our PT back, right? So we're going to have to figure out L. But in order to figure out L, we're going to need to find D first. So D1 equals the constant 5729.58 over I. Or no, so R. Sorry. That'd be R over R. So that equals 5729.58 over R is 1200. So D1 equals what? D1 equals what?
4.77.
Now this is, remember, it just gets displayed in degrees, so you gotta turn it to degrees. D is degrees. In degrees.
4 degrees, 46 minutes, and 29 seconds.
Okay. Alright, so we figured out D. Alright, so now we can figure out L. L1 equals 100 over I1 D1. So L1 equals what? I is 10. D1, we just figured out, 4 degrees, 46 minutes, 29 seconds. So L1 equals what?
It's supposed to be degrees.
Degrees, minutes, seconds. L is a length now. It's not degrees. L is now a distance. 209.44. So that's L1. Well, now, based on this up here, we can find our PT back. So PT back, so it'd be the PC plus L. PC station plus L will give us the PT back. 21 plus 29.45. Okay. So why is this significant?
Because you told me to.
No, this is significant in the fact that the station equation, when we get into this next curve, into the second curve, we're going to go back and start at the station ahead. Or station back, I mean. Okay? Because of the loss in curve going through. Alright? So when we figure out the stations for this, we're going to use these stations to get there. Now. Okay, we're going to use the ahead station. So now, I have my PI here for PI2. Let's figure out the second one. We're going to go through the same exact route that we did on the top here to do the second one, the second curve. Okay?
We're going to need to take into consideration the distance from P1, PT1 to PC2.
Yes, we will, after we get going. Yep, we will, for sure. Okay, so let's figure out, the first thing we want to figure out, we know what PI2 is. We're going to try to figure out PC2. Okay? So in order to find PC2, we need to find T again. So, and we know that that T2 is equal to R2 tangent of I2 over 2. So R2 is 600, tangent I2 is 18 degrees 00 minutes 00 seconds over 2. So T2 equals what? 95.03 feet. Okay, in that case then, if T2 is tangent, how am I going to find the PC2 then? So I'm going to take PI2 minus T2, and it's going to give me PC2. So what's the station at PC2? 30 plus 04.97. Okay. PI was PI2 is 31 plus 00. Okay. So now let's figure out PT2. So we're going to have to do the same stuff that we did on the top, up in here. We're going to have to find D again. So D2 equals 5729, the constant, 58, divided by R. R is 600, R2. What does that come out to be for D2? Remember, it's in degrees.
Yeah.
9 minutes, 32 seconds, 57.
So it's
9 degrees.
32 minutes,
9 degrees, 32 minutes,
57 seconds.
57 seconds. Okay. So that's D2.
Now, let's find out.
So like Skyler said, let's find out. L2 equals 100 I2 over D2. So this will be 100. I is 18 degrees 00 minutes 00 seconds. You can't see that up there because I'm moving off the page there. And D2 was 09 degrees 32 minutes 57 seconds. L2 equals
I got 188.4, 188.5 feet.
0.50 feet.
50 feet.
Okay, so that's L2. All right, based on what we know about L2 now, we can find our backs there for the PT. PT ahead, PT back. So our PT2 ahead and PT2 back equal what?
PT2 ahead is 31 plus 95 and
0.03. Okay, 31 plus 95.03.
Yep. PT back is 31 plus 93 plus 4.
Okay. So where this comes into why we want to figure out this ahead and back is when we go to lay out a curve. Okay? That's how it's going to work. That's how stationing is going to work. When we go to lay out a curve. So that's where this will come into account. When we start to do stuff by deflection angle, you'll see how that works. But you just need to know how to figure out the ahead and back. That's all I'm going to test you on. Tell me what the formula is for ahead and the back. Okay? Stationing. So we just basically solved number 5 on the homework here with this information. I ask you in there if you can give me the ahead and backs. Okay? So that's the example number 4 for station equations, which is also similar to number 5 on the homework. Okay? So I'll give you guys a little bit of time to copy this down and we'll move on to the next one. Alright,
All right, then.
2 weeks before terminal.
we'll get fired up on the next problem here. This will be example number 5. This is going to be similar to number 6 on homework. Spoon feeding you guys here, making you not have to think.
Number 6.
Okay, so I'm going to draw the figure in real quick.
You don't mind that, you know. Sometimes we learn better that way.
Pizza slice.
It's a pizza slice, look at that. Okay, so I've got A and B that I'm going to try finding here. I have to draw it out quick. Okay, so this is A, this is B. So I'm given a few things here, okay? So I'm given the radius of my arc is 360 feet. Okay, that's for the radius from here to here. And between my right-of-ways, it's 100 feet. Alright? My station at this point is 1 plus 0, 0. My station at this point, at A, is 1 plus 95. And my station here is 3 plus 50. Okay? So those are the things we know. All the stuff that I just labeled. So this here is my radius point. RP.
Is that A on the center point of the arc?
That is A. I'll write it bigger so you can see.
So that is the center point of that arc?
It's not a center point. No. If you look at the stationing, it's not a center point. It's just drawn that way graphically. I didn't draw it to scale. Okay. So the one thing we want to find here is I want to find the distance between A and B. That's going to be pretty difficult, right? Because we're on an arc. We're beginning on an arc and ending on an arc. So I want to find length A to B. Okay? And that's what I'm trying to find right there. Okay, so the easiest thing you can do here to find length AB. So let's turn some things into triangles, right? Everything comes back to triangles. Okay? So let's connect A and our radius point. We're going to draw a triangle in there. Okay? Alright, so there's a few things we can figure out without doing much work at all. Okay? We know our radius is 360 of this outer curve. Okay? And they tell us that it's 100 feet from this right of way to this right of way. So my radius here then, from here to here, should be 360 minus 100, right?
Should be.
Yeah. So this is 260 feet. Okay? We figured that one out pretty well, easily. We can figure out what our distance is here too, right? Distance here is 360. It's the radius. So this is 360. Alright, we got two of the items we need in our triangle. We should probably try figuring out an angle, right? Because we don't know the distance from A to B. That's what we're trying to find. So let me label these. I'm going to label my triangle just like I would anything else. Okay. So I just labeled my triangle. So let's take a look at and see if we can figure out some other stuff here. Okay. We want to figure out B. So we're going to try to find, one of the things we're going to have to try to find is this angle, which is going to be,
Half up or no?
it's not half up.
No.
This is going to be our I, is what we're going to try finding.
Would you assume coordinates?
Nope, can't assume coordinates. Let's start by finding D, okay? D equals 5729.58 over R. Okay? 5729.58 over R. What are we going to use for R? 260. We're going to use 260. Because we're trying to find out I for the small curve here. Okay? I for the small curve. So what's D?
22 degrees, 02 minutes, 13 seconds.
22 degrees, 02 minutes, 13 seconds. So that's D. Okay? Now that we found D, why don't we find L? So we want to find out what this distance is here. What's L? Oh no, we're going to find I, but let's find I. But we're going to need to use this equation to find I, so we're going to have to do some substitution to get the equation to reflect I. So how would I do that?
2 times the inverse tangent of divided by R.
How about that?
Yeah.
Let's bring the L over and bring D up and drop 100 down. Okay? So now we can find I. I know what L is. I can figure out L. L is easy to find. Right? L is the distance along the curve, right? So you should be able to just subtract the stations. So this station minus this station should give me L because it's the length along the curve, station line. So L is equal to 3 plus 50 minus 1 plus 95. So L equals what?
1 plus 55?
Well, 155 feet we can call it. We don't have to put the plus in there for that one, for L. But it's 155 feet. So I know L now. It's 155.00 times D. We figured out D, 22 degrees, 02 minutes, 13 seconds, divided by 100. So I equals what?
34.15 or 34.16.
It should be in degrees.
In degrees?
Yep, I is always in degrees. It's 34 degrees,
7 minutes, 15 seconds.
5 minutes.
09 minutes.
26. It says 26.15 seconds.
26 seconds. Okay, so we just figured out I. Okay, so that's here. This is I is also B. That's what we're looking for. Because we solved for the smaller curve, right? If we were solving for the larger curve, we would have used 360 in the equation here when we found D. Okay? We were solving for the smaller curve, this one. Okay?
Pretty cool.
Alright, so now we found I, which is also B. What do you figure we should use to find this distance then, right? We have our side, angle, side.
Science. All science.
Law of sines or law of cosines.
All science easier.
Sure.
Either one?
I figured out by cosines what I did.
Okay.
Alright.
So I just used law of cosines. I'll write that on there.
B squared. A squared.
So I have b squared equals a squared plus c squared minus 2ab cosine of b. Sorry, 2ac. I wrote b there in accident.
All science. Equation.
There. So b squared equals a is 260 squared plus c is 360 squared minus 2a is 260 c 360 cosine of b, and b is our I. 34 degrees, 09 minutes, 26 seconds. So b squared equals what? I'm looking for b squared, not b yet.
That's a lot of buttons.
It's a lot of buttons. What is it? B squared. Give me the number for b squared before you actually take the square root of it.
42,291.99956.
Let's go 999. Okay, so this is b squared. Now, what is b then?
205.65.
205.65 feet. That is the length okay, so that's A to B. Pretty simple, right? This is how you're going to tackle every single one of those problems from 6 to 10. You're basically breaking them into triangles. Can be somewhat confusing. I'm going to do one more of these, and then the rest of them I might let you try on your own. And tomorrow we'll maybe start the deflection. You look at the example problem number 7, homework problem number 7. It looks similar to what I just laid out here. Okay, it's going to be example problem number 6. Okay, so we want to find the distance between distance and bearing between A and B. Line AB. So we're looking for right there. Okay? So there's one very major principle you need to know. And that is... Which way is north? Yeah, I like it. Where a PC or PT occur, that's perpendicular, always perpendicular to the tangent. Okay? That's going to be very important on how you solve this problem. Okay? So knowing that and being armed with that, I should move A over a little bit because it's not going to be perpendicular.
So are we
graphically.
assuming A or B is a PC or PT?
Yes.
Okay.
Okay? So A and B are PCs or PTs of these curves. I don't know what direction we're heading, so I can call them either one. So, knowing that they're perpendicular, I can quick figure out that if I draw a line here, that distance from here to there is 125 feet. Right? Same thing over here between B and its radius point. That's 150 feet. Or 250 feet, sorry. Okay, so that's 250 feet. Now, because these are both perpendicular to this tangent line, I can figure out a square or a rectangle. Right? Because if this is 90 degrees and this is 90 degrees, if I come up exactly 125 here, these should be 90 degrees. Right? So we're getting somewhere.
Yeah.
Not quite there yet. But we're trying to figure it out as we go. Okay? So now I sort of figured out these. I don't know my distance along here yet, so that's going to be sort of difficult to do. But I can, if I draw my triangle here and connect the radius points, okay, I connect my radius points, I should technically be able to figure out this bearing and distance here, which will help me figure out the bearing and distance down here. Okay? Well, I know if this is 125, this line here is going to be 125, right? And this is a right triangle, or a right angle here. So this distance is 125. All right? So let's figure out our bearing here then, because we're given coordinates for those two radius points. We should be able to figure out the bearing and distance of this line between the two radius points. So that's the old, the bearing is inverse tangent of the departure over latitude.
60 to 65.
So the tangent, this one, it'll be 365.00 over 60, right? Change in latitude and departure. That's all it is. I should put change in there. So what is the bearing?
Are we assuming north is up?
5, 6.
Yes.
Okay.
Well, okay. Someone tell me where north is based on the coordinates we have.
Oh yeah, I guess that one. That's,
It is up.
yeah.
Yeah, if you pay attention to the coordinates, it'll tell you what direction and everything is, which way north is.
So it's positive and positive.
Yeah.
Yeah, north 80 degrees, 39.
(80°, 39
Minutes,
minutes,
54 seconds
54 seconds
east.
east. Right? We're heading northeast direction. Okay, so we just figured out the bearing. That helps us. So north, 80 degrees, 39 minutes, 54 seconds east. Alright, let's figure out the distance then. So distance is equal to square root of the departure squared plus the latitude squared.
So 360 or 365?
So it's 365 squared plus 60 squared. What's that going to give us for the distance?
369.90.
369.899. Alright, so we got the distance now for this hypotenuse, we'll call it. 369.899. Right?
Yes.
So, what should we look for next?
An angle somewhere.
Well, we should probably, let's see if we can find this angle here, theta. Okay? So should we use the law of sines for that, you think? Because we have side angle,
Side angle side.
side angle side. Yes, it is.
What are we? Are we trying to find
I want to find this angle here.
AB as a distance?
Oh, we can't quite see what you're right.
Sorry.
If we
Trying to
know-
find that angle right there. I've got. Oh, hang on.
Yeah, why don't
Before we
you-
find it, let's find this, right?
Because that's just a.
Let's find this distance. So then we'll have side, and we'll find the angle, right?
But wouldn't that, since you got it's a square, if we find that, that is AB?
Yeah.
Then we don't need to know the angle?
No, we need to know the angle. We need to know the angle to figure out the bearing. We gotta figure out the bearing and distance
What is the bearing and distance?
of A to B.
Well, we can get the
Find the bearing and the distance from A to B. Yes, we can find the distance right now. You wanna know how we're gonna do that?
Cosine.
Pythagorean theorem.
Pythagorean theorem.
Oh, okay.
Okay, so
That's easy.
Pythagorean theorem. Good old Pythagoras. Let's see if I can.
B squared equals C squared minus A squared.
So, square root of 369.899 squared minus 125.00 squared. It's going to give us the distance here, which is the same as the distance on A and B, because these are a rectangle. So what do we get there? 348.14. So this one's 348.14, and this one is 348.14. Right. Now let's use the law of sines to figure out theta. So theta equals the sine of A. So angle A, I'm going to call it A. This will be A. Little a. B. C. Okay. This would be C. C's 90 degrees. So little a equals A over C. Ready? So sine of A equals A over C. A over C. So 125.00 divided by 369.899. I labeled that backwards. We'll see if it comes out. I doubt it will. I might just be figuring this one here. It's opposite over Jason. I think this is supposed to be 348. This should be B.
So is opposite over hypotenuse.
Opposite over, right? Hypotenuse.
It's gotta be sine -1 though.
Sine of -1.
You don't have an angle right now. So you
Yeah, we don't.
Sine -1,
Yeah.
sine inverse.
Inverse sine.
And then you're good.
Yeah. All right.
Which is 19 degrees.
45
Five,
minutes.
45 minutes. 3 seconds.
I figured it wrong. These, I labeled these all wrong. Call that A. This B. Or we'll C here. B, C, A. There we go. So this should be the 348.
No, you're right.
No, I got her. This is the correct way. I got her. I got her. I got her. This shouldn't be. That'll be inverse sine when you bring it over. That'll be inverse sine. I'm leaving sine on that side until the end, and then I'll flip it over there. So then A will be inverse sine of whatever this answer is from up there. I don't have a calculator, else I'd do it.
21 degrees.
There we go.
0.02 minutes and 31 seconds.
Alright, so that A, which is also its theta. Okay, so we just figured that angle, which is 21 degrees, 02 minutes, 31 seconds. Angle anymore. All we need is this bearing. So we're just going to take, because it's a northeast bearing, north 80, 39, 54, what's the azimuth there?
80, 39, 54.
Exactly, it's 80, 39, 54 is the azimuth. So we can just add these two, and it's going to give me the azimuth of this line. Okay, so it's
This works.
azimuth equals 80 degrees, 39 minutes, 54 seconds, plus 21 degrees, 02 minutes, 31 seconds. It's going to give me what azimuth?
101 degrees, 42 minutes, 25 seconds.
25 seconds, did you say? Okay, so that's our azimuth now for this line, which is also the same azimuth as line AB.
I got a phone there.
Okay, so now let's turn it into a bearing then. So I'm just going to take 180 minus this, and that's going to be my bearing.
South 78 degrees.
Hang on for a second. Go ahead.
South 78 degrees, 17 minutes, 35 seconds east.
Okay, so it's a southeast bearing because we're heading southeast.
Yep.
So it's a southeast. So the bearing there now then, south 78 degrees, 17 minutes, 35 seconds east. Okay?
That's it.
So we turned our azimuth into a bearing. And that's what our bearing is here. We figured out the bearing and azimuth for this line, but these two lines are parallel by the way we set up our figure. So all that just to find line, the bearing and distance of A to B on this figure. Now, this is pretty much a mirror of what you're going to be doing on problem 7
Yep.
in the homework.
Yes. Definitely a mirror.